All right, great. My name is Niels Ouwersloot. I'm going to be speaking about Engineer to be Green. I'm going to be providing a practical guide to introducing sustainable approaches in machine design and redesign. I studied industrial engineering and worked as an engineer for a while, and now I'm in sales. I have over 15 years experience in automation. And one of the reasons I wanted to talk to you guys today is when I was an engineer, I would analyze my problems through a Pareto chart analysis. The biggest problems you attack first and the little problems you deal with later. Well, I've been to a few of these seminars, and about 6 months ago I went to a presentation on sustainability, and it was about optimizing your garbage pickup. And I was sitting there thinking, there are much better ways to approach sustainability. Just to reduce the pollution from a garbage truck didn't seem to me to be as major of an impact as it could be. Now, over my 40 minutes in that presentation, I learned it does have some merit, but I think I have a lot more to share with you. I'm going to be talking about machine design, and this I think is relevant for company owners, for maintenance personnel, for machine designers, for machine builders, and for plants in production. I do work for Beckhoff, and I'll tell you a little bit about Beckhoff. It's a privately held German company. It's almost $500 million. It's based on the philosophy of open automation executed with PC-based controls. It's a strong history of innovation and growth. Beckhoff, in fact, invests over 10% of revenue into R&D. So not 10% of profit, but 10% of revenue. So it's a very technology and engineering driven company. And Beckhoff is found in all kinds of applications that are here today in packaging, plastics, medical, CNC, building automation, and a lot more. So I covered the introductions, and I'm going to talk about what is sustainability and going through some practical steps to get there. And at the end, I'm going to have an example. This will be a reverse Pareto having the biggest impact at the end. It's only 20 minutes, so if you can stick with me, I think everybody should get at least a couple points out of it related to the show today. So first, what is sustainability? Actually, it's just being simply considerate of our natural environment. It's not much more than that. Walmart has done extensive research on the topic and relates the following main points of sustainability that I found related to manufacturing and machine design and controls. They talk about energy efficiency, material efficiency, and using low impact materials, eliminating waste, recyclability, and also consideration of our natural resources by using as many renewable natural resources, doing quality and durable design, which means that a product will last longer, and in our case, maybe a machine can be used longer or reused. Eliminating waste, and again, not polluting. There are some rules that talk about sustainability, like the EPA environmental laws and some existing industry regulations, but there's really no established rules pertaining to sustainability of controls yet. But we all know it's coming. And if it's not by law, there are a lot of external and internal forces asking us to be sustainable. That's why we're here today. We have internal in our own companies, we have marketing groups that want to present your companies as sustainable, and you have your own customers asking you to make more sustainable devices. And I think you can do a lot more than implementing just a recycling program or a garbage management program. And I'll also make the case that I think you can be green two ways simultaneously. You can be green environmentally and cost conscious. I also thought that this presentation would sound more legitimate coming from a long-haired bearded feller as opposed to a Wall Street gentleman. So let's turn the jargon and hype into profitable process. I'm going to skip by all of the high-level talk because I just want to, I only have 20 minutes, and I just want to give you some real take-home ideas that you can use in your plants and on your machines. So first things first, you have to measure and compare what impact you're having. You can measure your electrical power consumption, measure your machine footprint and the panel size, measuring the machine output. You're going to measure the product itself. the weight, the size, the raw materials used, and then you can start reducing your impact. I'm going to make the case that you can reduce your impact by reducing the number of devices and not throwing away good parts. And then also taking it further, I want you to consider that higher performance is higher sustainability. And I'll make the case for that in just a little bit. I think this is an iterative process to measure, improve, and compare. So you won't just go through it once. It's going to be a continual thing, just like many processes in your facilities. So let's look at some common machine controls. Many of your machines in your facilities and your plants, whether you're making a machine or whether you have production, is going to have at least one of these, if not many of these, and in sad cases, most of these. A PLC, motion controller, HMI, safety controller, remote access and gateway computer for internet and remote accessibility to a machine, robot controllers, temperature controllers, Ethernet switches, network scanners, network adapters, energy management, data acquisition, black boxes, and a lot more. Now, I say, can any of these be eliminated? The design engineers in the building today, they're going to say, yeah, I'd love to eliminate it, but you'd also eliminate your job. I'm going to say you don't have to get rid of the process, but how about getting rid of the device? An analogy to this is a modern day example, and not long ago we had telephones that just were used for calling. We had game systems that were only used for gaming, GPS systems that were dedicated GPS systems, pagers, computers, iPods that only played music. It's all gone into our phones today, and in the same way, controls are consolidating into one device. So why would I want to reduce the number of devices? Extra devices can have a significant impact on sustainability. They consume more electricity than leaner systems. They generate more heat than leaner systems. They require excessive wiring. There's also production and end-of-life impact. More plastic used for production, more energy for manufacturing the devices. And then you have general waste with the packaging at the front end, or electronic waste at end of life, which is a big issue now. We're all having to recycle old electronic devices. So if we can eliminate the waste and reduce the pollution as much as possible, what starts happening? Well, when you start taking out motion controller as an example, you can start removing other devices too. Power supplies, fans, circuit breakers, relays, air conditioning in control panels. A lot of machines have air conditioning on the machine. And then you start reducing the panel size too. So now you start reducing the machine footprint. So less devices means less required space. And this can all have a cascading, if not geometrically, effects on sustainability. And on your next machine upgrade, you could consider getting rid of as many of these devices as possible, maybe putting it into one device. I'm going to show you one way to do that is you can reduce the number of devices with industrial PCs. The increasing power of PCs with multi-core processors, the work of a lot of these traditional standalone devices can now be handled by one device. So your PLC, your motion, your HMI, your internet connectivity to your machines, your OEE reporting, all this can be hosted on just one device. Processors like the Intel Atom don't even need a fan. They have lower heat, lower power consumption. And there's also a lot of PC options that don't require fans, like the picture at the bottom right is an example from Beckhoff that has a dual-core processor and doesn't require a fan. All this can be done on one platform, one software platform, like a EtherCAT from Beckhoff, and based on one operating system. I should also add that, yes, I'll be speaking from a Beckhoff perspective, but there's a lot of vendors here today showing a lot of these technologies, and this is just an example. You can also reduce your devices through more efficient bus networks. These are the communications that we have between these traditional devices. If you use a network with more of the following characteristics, you can also design more sustainable machines. If you base your evaluation on a network that is more high speed, real-time and efficient, so you don't need separate localized controllers on the machines, such as motion controllers, temperature controllers. You can start putting that in the one device and not having remote devices throughout a machine. If you have a network that doesn't require a lot of CPU per se, and one that doesn't require switches, routers, or IP addressing, again, you start reducing hardware. Flexible topologies also reduce hardware. I'll take that applause. Flexible topology, like line, tree, star, ring, allows you to do what you need to accomplish without being limited by hardware. And for practicality, I would also throw in that you should consider that open technology won't lock you into one vendor per se. And if a network can support integration of your legacy field bus systems, that can help, because you're not going to be able to change everything all at once. So one of these networks is called EtherCAT. EtherCAT is an efficient protocol within the framework of 802.3. That's an IEEE standard that defines what transports the Ethernet frame and the way it's packaged. EtherCAT uses a standard Ethernet frame. It has a standard header and a standard frame length. But EtherCAT is not Internet. Internet is Internet protocol. That requires local area networks, it requires wide area networks, switches, routers, hubs, and often IT guys too. So because we can generate EtherCAT frames from a standard Ethernet port on a PC, you don't need expensive dedicated EtherCAT field bus cards. I also want to say again, I do come from a Beckhoff perspective, but this is not just a Beckhoff thing. EtherCAT is an open technology. There's a lot of vendors here today showing EtherCAT. It is a Beckhoff invention, but it's its own standalone technology group. It's the largest dedicated industrial Ethernet organization. There's over 1,450 members worldwide. There's 103 controllers that are EtherCAT masters. That means Beckhoff is one of them, but there's 102 others. Again, I'm just making the case that EtherCAT is sustainable and not per se up here talking about Beckhoff. There's 81 servo drive manufacturers, 47 I/O vendors, and 23 operating systems, including Windows, but also Linux and many others. And it's open to everybody. So how it impacts sustainability is it requires less hardware, reduced requirement for localized separate controllers because you have this high bandwidth, high speed network. It eliminates black box controllers, and it just uses standard I/O. And no switches, hubs, or routers, or IT guys. And it also generates less waste through greater precision. A more precise machine is going to generate less waste. EtherCAT is capable of 10 nanosecond timestamping. So more efficient networks require lower computing power. You don't need the latest, greatest Intel processor to run an EtherCAT-based machine. And there's no funny extra hardware like end resistors or T connectors, anything like that. Now there's other technologies to consider when trying to make your equipment more sustainable, and you can reduce your energy consumption through motor selection. For example, this is a screenshot. I know it's a little hard to see, especially under the lights, but we are showing an asynchronous servo motor versus synchronous servo. And a synchronous servo motor is doing the exact same job with the exact same motion profile, but it's using only 33 watts instead of 73 watts. So over a lifetime of a machine, that's a lot of power consumption that you could be saving by just choosing the right technology. Now, when it comes to this servo selection, also consider the mechanical design. I worked with a customer recently, a few months ago, that decided that we sized a servo application, and we came up with a 12 amp servo drive. And we said, gee, that seems a little bit big. What if we redesign the mechanical mechanism? So we reduced its inertia, and it wasn't a lot of work, and we went from a 12 amp drive to a 3 amp drive. So that's another way that you can start considering making your equipment more sustainable. So you start throwing out some devices. How would you know that you're green? Well, as I said at the beginning, you'd have to start measuring it. There's a lot of ways to measure it. One example from Beckhoff is that we offer an input-output terminal that measures power consumption. And once you have the information, you can start doing something with it. So you can start analyzing it and seeing, well, maybe I want to run my machines when electricity costs less, or gee, it's consuming a lot of electricity. Is there a way to reduce that impact? Another way to reduce to improve your sustainability is to reduce machine parts through the life cycle. Consider predictive maintenance instead of preventative maintenance. Preventative maintenance essentially says like a bearing manufacturer, as an example, might say, my bearing's going to last 3 years in this condition. Well, after 3 years, you take it out and throw it away. Well, maybe that you don't know, you just prevented it failing. But if you consider a process like predictive maintenance using condition monitoring, you can put a vibration sensor on that bearing and you can actually start measuring the vibration of the machine. Now, you could possibly sense that the machine is operating inefficiently before it was supposed to fail, and then you can schedule your downtime and not affect your throughput. Or you could start, or you could realize that after 3 years, maybe it's not failing, and you can continue to run the part, and so not throwing away a good part. Condition monitoring is a process that requires an input device as well as some software. But the software, again, you can host on one localized controller. It does some you could do some complex math like fast Fourier transforms that I would like to forget from college, but they haunt me. Digital high pass filters. So you eliminated unnecessary devices and eliminated some waste. You established some measurements, and then what's next? Well, here's where I think you can have some of the most impact. If you consider the machine's output and its effect on sustainability, can you improve it? A higher performance machine is more sustainable. Higher production throughput requires fewer machines to manufacture the same or higher amount of goods. Faster machines enable end users to run machines less or schedule when power or utility costs are lower in the evenings, reducing the strain and reducing the impact on our environment. They'll use less materials, less waste during production, less waste from starting, stopping, and setup. Setup can create a lot of waste as well. So one way to improve the performance is through XFC. That's extreme fast control. It's combining EtherCAT bus network that I talked about earlier with PC-based control and TwinCAT software. You can do 10 nanosecond time stamping, and you can do I/O response times of 100 microseconds. It uses standard devices, so an input device from a sensor might only be $100. It's not per se very expensive, and it can greatly improve the performance. So here's an example that's pulling a few of these things together. One of the beauties of this example is that you don't have to do everything all at once. Husky Injection Molding is the world's largest brand name in supplier of injection molding equipment. And Husky Injection Molding was already using PC-based control, and they were challenged by reducing the cost. But they have strong initiatives for sustainability, and they realized they wanted to, in this case, they were making plastic cups. And they know that by using less plastic, using thinner wall thickness, uses less material, and of course it's lower cost. But it's not as easy as it sounds, or everybody would be doing it. There's a lot of thermodynamics involved, cooling lines, a melt flow, and frozen layers, and it's not as easy as it looks. So this is their current architecture. And all they added was actually only about $300 in hardware. They added some extreme fast control, inputs and outputs, and they did not change their software. They just made their software run faster. So this is actually the pressure curve for pushing plastic, the molten plastic, into a mold. And that's the desired curve. And what they had was this curve, and this is just a PID loop, and it was operating at 2 milliseconds, and you can see its delay in response, and you can see it overcompensating and being over dampened. With XFC, they went from a 2 millisecond response time control cycle to 250 microseconds. You can see that the red curve is much closer to the desired curve that they wanted. So that sounds really technical and amazing. Well, that's why we have engineers applying these things. But what happened? What was really the result? They started with a part that weighed 22 grams. They ended with a part that weighed 20 grams, with 8 parts per mold, making over 54 million parts per year. And I know a lot of your production facilities will make more or a similar amount of parts. 2 grams has an amazing impact. 2 grams is 125,000 kilos. It's 125,000 tons. Over 250, almost 275,000 pounds of plastic saved from this. I mean, that impact on the environment alone is amazing. And the savings were over $180,000. So Husky, in this example, made a machine that's more sustainable, reduced the impact on the environment. They had a more efficient use of raw materials and improved energy efficiency, less energy consumption, through a smoother process because the pushing of the plastic was so much smoother. They actually reduced part wear as well, and of course plastic's a highly recyclable product. They had a lot of side benefits too, so better injection repeatability and lower maintenance, reduced noise levels. So this shows how higher performance can have an immense impact on sustainability. So just summarizing some of the issues I made a case for today is reducing your automation hardware footprint. I showed how you can reduce the devices you have on a machine through either industrial PCs and faster bus networks. Considering predictive maintenance, that's actually measuring what's going on, versus preventative maintenance, which is a guess. You can produce more using less, so fewer machines could produce more with higher performance, and producing less waste. More efficient and more accurate machines produce less waste. So I showed it's possible that you can have sustainability as an objective side by side with profitability, and there's a legitimate business case to do both. I do want to say that there's an evolution in controls that's happening today. Industrial PCs are doing to PLCs what PLCs did to relays over 30 years ago, and all this is green and it's profitable. So with that, I'd like to end my presentation, I think right on time, and open it up to any questions.